A majority of drugs found in the common world today originate from plants. These drugs, such as caffeine and nicotine, can be lethal in high quantities, but for many different species, small amounts of these drugs, such as caffeine, are mildly rewarding and enhance mental performance and memory preservation. A new research has been conducted that plants have evolved to use these drugs, such as caffeine, to enhance memory of reward, thus securing a pollinator's loyalty and proving reproductive success. G.A. Wright published and conducted this experiment on caffeine and nectar enhances a pollinator's memory of reward. The aim that was obstructed in this experiment was to determine that caffeine could affect the learning and memory of foraging pollinators. The experiment was originated by using plants that naturally produce caffeine in their nectar, which included the Caffeine and citrus species. The concentrations of caffeine in these plants range from 0.0003 to 0.253 millimoles. So this was how the concentration of caffeine in the experiment was drawn up. To test the hypothesis, individual honeybees were trained to associate floral scent of 0.7 moles with 7 different concentrations of caffeine and tests of olfactory memory. Using typical feeding behavior of the honeybees, the bees were trained for 6 trials with 30 seconds between each combination of odor with the reward. Figure A shows the results that in the presence of low doses of caffeine in reward had a weak effect on the rate of learning, but it had a profound effect on the long-term memory. This can be easily seen with the shape of the curve as a number of trials progressed. As the concentration of caffeine increased in the trials, the more times the bees remembered. 24 hours later, 3 times as many bees remembered and responded as if they predicted reward of the caffeine. In Figure B, it is demonstrated that the white bars are the memory response to the odors after 10 minutes. All the red bars show the memory to the odor after 24 hours. The bright red bars indicate the response at 24 hours was significantly different from the control, while the dark red bars indicate they were not significantly different. And after 72 hours, Figure C shows that still twice as many bees were more likely to remember the caffeine in sucrose, the orange bars, compared to the odor of the sucrose alone, the white bars. After the testing was completed, it was found that caffeine to honeybees is both toxic and repellent over the concentrations of 1 millimole. This implies that pollinators drive selection towards concentrations of caffeine that are not repellent, but still pharmacologically active. So by affecting a pollinator's memory, plants reap the reproductive benefits arising from enhanced pollinators' fertility. Thank you for listening.